2.3 linear equations. This is a continuation from 2.2 linear equations. So we're going to continue graphing, looking at lines, how to write an equation, parallel and perpendicular lines, and knowing the three forms: slope, intercept, point slope, and standard. So it might have been a while since you have used point slope. Point slope form is y minus y1 equals m times x minus x1, where m stands for the slope, and then x1, y1 is a point. Slope-intercept form, y equals mx plus b, and standard form, ax plus by equals c. Now, one thing that we did not talk about in section 2.2 was that you can find slope when an equation is in standard form by taking the opposite of a divided by b. So sometimes that comes in handy. When it's in standard form, you can find slope by finding the opposite of a over b. So let's take a look at number 1. Given the equation 8x minus 4y equals 12, find the intercepts, like we've done before, and the slope, so that will be new, and then we graph it. All right, so remember, when we're finding the intercepts, we essentially need to put a 0 in for y and solve for x. So if we put a 0 in for y, we have 8x equals 12. Divide both sides by 8, so x would equal 4/3. All right, and then we're going to put a 0 in for x. So we have negative 4y equals 12. Divide both sides by negative 4, so y is going to equal negative 3. So we have our x-intercept and then our y-intercept. Now our slope, our equation tells us that we have to take the opposite of a over b. So our a value is 8, so negative 8 over our b value of negative 4, which equals 2. So we're going to have a slope of 2. All right, so then we're going to go to graph it. And, oh goodness, I just noticed I simplified that wrong. When you divide both of these by 4, did anybody catch that? This would be 3 over 2. 3 over 2, which is about 1.5. Sorry about that. All right. So, if I have 1.5, I'm probably going to count by halves then. So this is going to be 0.51, 1.52, 2.53, and then on the y-axis, I don't have to count by 0.5. I can just count by 1, negative 2, negative 3. And then connect both of those. Okay, so we graphed our x-intercept and our y-intercept, and you'll notice your slope still works too. So if you go up 2 over 1, up 2 over 1, your line is going right through there. It's kind of a bonus check to see if you've done that right. And had I not caught myself on this and graphed the wrong number, it would have been nice to have the slope to see that I had not graphed the right point to go back and look. All right, let's take a look at number 2. We have some fractions in here, okay, but we are still gonna try to find our x and our y intercepts. Oh, I'm sorry, it says solve it for y, then graph. So we don't have to find our x and our y intercepts. It wants us to solve for y. So let's get y by itself. We wanna start by subtracting 4/5 x to the other side. So we would have 1/8 y equals negative 4/5 x plus 5. And then we don't like these fractions. To get rid of this, to get the y by itself, we would have to multiply everything by 8. Okay, so we're going to multiply this by 8, multiply this by 8, multiply this by 8. Everything gets multiplied by 8. All right, so we're going to have y equals negative 4 times 8 is negative 32 fifths x plus 40. And that, some of you probably changed that to a decimal. Our slope is negative 6.4. Now that it's in slope-intercept form, it's like easy to identify the y-intercept as 0.40. So it says solve for y and then graph it. Well, obviously if we need to graph 0.40, we're going to have to do some adjusting to our scale. We can probably count by 5, so 5, 10, 15, 20, 25, 30, 35, 40, and our y-intercept goes way up here. Now our slope, negative 6.4, so we'd go down negative 6.4 over 1 if we're counting by ones here. Down negative 6.4 over 1. Okay, it's kind of hard to go down negative 6.4 because it's such a strange number. So another way to check to make sure your points are in the right place, you can substitute values into your equation. So for instance, I can substitute the point 1 in for x and do 1 times negative 6.4 plus 40, and I get 33.6. And hopefully that's about where I put that. Maybe a little too high. Or I could put 2 in and do 2 times negative 6.4 plus 40 to get 27.2. So 2, here's 25, 27. Yeah, that one's about right. So you can do that also if the slope is a little off. Number 3, find the equation of a line with slope negative 3 that contains the point negative 2, 5. Give the coordinates of 2 additional points on the line as well. Okay, let's start with the first part. Find the equation of the line with slope negative 3 that contains the point. So they gave us a slope and they gave us a point. Anytime you have those two, you want to use the point slope equation because you can substitute them right on in. So remember, that's the y minus y1 equals m times x minus x1. So we are going to substitute the y value in for the y1, the slope in for the m, and the x value in for the x1. Since it was a negative x value, it becomes a plus 2. Okay, and then we just simplify that. So we distribute the negative 3, negative 3x minus 6, and then add 5. And when we do that, we have now put it in slope-intercept form. So y equals negative 3x minus 1. All right, so it asks us to find 2 additional points that are on this line. Well, I'd say an easy one to find would be the y-intercept because it's right there. So 0, negative 1 would be 1 point on the line. And then just, you can pick any additional point to find. 1 is probably pretty easy to substitute in. Negative 3 times 1 is negative 3, minus 1 is negative 4. So there's 2 points that would lie on that line. Oh, sorry. There you go, now you can see that a little bit better. We have our y equals negative 3x minus 1, our y-intercept of 0, negative 1, and our point of 1, negative 4. Number 4, find the equation of a line parallel to this line that contains the point 8, negative 2. All right, so hopefully you remember that parallel lines need to have the same slope. Okay, so if you remember how to find slope when it's in standard form, we do the opposite of A over B. So we need to do negative 3 over 4. So we want our line to also have the slope negative 3 over 4. So since we have slope and a point, we're going to use that point slope form again. So y plus 2 equals negative 3/4 x minus 8. It just says find the equation of a line. It doesn't say what form it has to be in, so we can leave it just like that in point slope form. Now you're welcome to solve it to slope intercept as well, but since the directions didn't specify to do that, we can also leave it just like this. All right, now let's try one of those, but perpendicular. Okay, so find the equation of a line in slope-intercept form perpendicular to the line 3x plus 4y equals 9 that contains the point 12, 6. So again, we're going to do the opposite of A over B to find the slope. But since we want it to be perpendicular, we need to make it the opposite reciprocal. So since this was negative, ours needs to be positive, and we need to flip that to do the reciprocal. So we are using the slope 4/3. Then we're going to put it into slope-intercept form. So y minus 6 equals 4/3 times x minus 12. Notice that the directions this time wanted our final answer in slope-intercept form. So we put it in point slope to begin with, but we have to keep going to get it to slope-intercept. So we'll distribute the 4/3. 4/3 times negative 12. I divide first, so negative 12 divided by 3 is negative 4, times 4 is negative 16. You can also use your calculator, but sometimes mental math is faster. All right, then we're going to add the 6. So we have 4/3 x minus 10. All right, number 6. Find the equation of a line parallel to the line y equals 3 that contains the point 4, 9. All right, lots of things we have to think about in this one. First, parallel, meaning the same slope. Y equals 3. Remember our HOI acronym? That's telling us that we have a horizontal line that goes through 3. So if we want it to be parallel, we need another horizontal line. So we need a horizontal line that goes through 4, 9. So since horizontal lines are made by y equals equations, all we do is pick the y value from the point, and our equation is y equals 9. Number 7, find the equation of a line perpendicular to the line y equals 3 that contains the point 9, 4. Okay, so same equation we had before, so it's still HOI, still a horizontal line, but this time we want it to be perpendicular. Well, what kind of line is perpendicular to a horizontal line? If you said vertical, you are right. So vertical lines are perpendicular to horizontal lines. So vertical lines, we use the acronym VUX, meaning we need an x equals. So x equals 9 in this case. So x equals 9 is our equation. All right, last one. Write each line in slope-intercept form and state whether they are parallel, perpendicular, or neither. So to write it in slope-intercept form, we have to get it so that the y is by itself. Y equals mx plus b. So essentially we want to solve for y. So in this first one, we start by adding 5x. So we have 4y equals 5x plus 8. Divide by 4. Y equals 5/4 x plus 2. Okay, that's in slope-intercept form now. Let's do the next one. We want to get y by itself, so we'll start by subtracting 4x from both sides. So we have 5y equals negative 4x minus 15. Divide everything by 5. So we have y equals -4/5 x minus 3. All right, so the slope of this first one is 5/4, and the slope of the second one is -4/5. Well, if you take a look at those, you'll see that they are opposite signs and they are reciprocals. So that means that these are perpendicular to each other. So we got our lines written in slope-intercept form, and then we compared the slopes to determine if they were parallel, which would have been the same, or perpendicular, opposite and reciprocal, and they were. All right, thanks for bearing with me on that one. I had a few slip-ups. Appreciate you understanding everybody makes little mistakes here and there. And I may have even said a few things wrong, but hopefully you followed along enough to be able to comprehend some of that.